In this video, we're going to talk about operations with polynomials. The operations we'll concentrate on are with addition, subtraction, multiplication, and division. When we add polynomials, we are simply combining like terms and writing in descending order. When we subtract polynomials, we need to be sure to distribute the negative to all terms in the quantity that we are subtracting. Then we combine like terms and again write in descending order. For multiplication, we have a few different techniques that we'll be talking about today. The basic rules are to multiply coefficients by other coefficients and apply any exponent rules that need be. Most likely that's the product rule. We can distribute, and some of you know that as the FOIL technique, but remember FOIL is only used for binomials. So if we have other types of polynomials like trinomials or multiple term polynomials, then distributing is the way to go. Finally, we'll work with dividing by a monomial term, so I'll show you the separate and simplify technique. To add or subtract polynomials, make sure you're checking what the sign is. So I've got a quantity added to another quantity. So with this plus sign, a positive 1 is actually being distributed to every term in the quantity. And we know that multiplying by positive 1 does not change the sign of the terms. So basically, we are just removing the parentheses. So our first term is negative 7x plus 5 minus 3x squared plus 7x plus 5. So scanning, I'm looking for like terms to combine. I see that negative 3x squared is the only term with x squared. So I start with that highest degree term. Remember, degree is just another name for the exponent. Next, I'll look for my first degree terms. I've got a negative 7x and a positive 7x. Well, negative 7 added to 7 is 0, so I don't have any first degree term remaining. That leaves positive 5 plus 5, that would make plus 10. And there we have added our polynomials. Notice the final answer is written from the highest powered term to the lowest. In example 2, we have subtraction. So the negative is actually multiplied by each term in the quantity. So 2x squared plus 5. Negative times 3x squared means we're subtracting 3x squared. And negative times negative 9 turns into addition of 9. So I have some like terms with my x squared terms. 2 minus 3. Those are the coefficients that are getting combined to make a negative x squared. Then I have 5 plus 9, that would be adding 14. So we have our simplified term, negative x squared plus 14. Here we just have another format for showing subtraction. I've lined up the terms vertically instead of side by side horizontally. Since it is subtraction, we will distribute the negative to each term in the quantity, and what happens is the sign of every term will change to its opposite. So it becomes plus negative 3x to the fifth, negative 6x squared, plus x plus 8x, and minus 2. So my fifth degree terms, 5 minus 3 would make 2x to the power of 5. Negative 4 and negative 6 make minus 10x squared. Positive 3 and positive 8 make positive 11x. And finally, negative 7 and negative 2 make minus 9. So remember that when you are subtracting a polynomial, that negative needs to be distributed to every term in that polynomial. Then you're combining your like terms. One application problem that could be done with addition of polynomials is the perimeter of some shape. Now this shape is four-sided So I'm just going to pick one place to start with x squared, and I simply add all of the other sides to that amount. So I'll just continue in a clockwise direction. So I'm adding that quantity of negative x plus 3. Then I'm adding 9x. And finally I'm adding this trinomial. And that's x squared minus 2x plus 4. So if I have a plus sign outside of the quantity, I'm distributing positive 1 that does not change the sign of anything. So I can simply remove the parenthesis. X squared minus x plus 3 plus 9x remains the same. Again, I have a plus outside of the quantity, so the signs will not change. So I'm just looking for like terms to combine, starting with the highest powered terms. That would be my x squared terms. So 1x squared plus 1x squared makes 2x squared. Then my first degree terms, negative x plus 9x minus 2x. So there's 3 that I'm combining. Negative 1 and 9 make 8. 8 take away 2 would make positive 6x. And finally, 3 plus 4 make positive 7. So you can see 2x squared plus 6x plus 7 is written from the highest to the lowest power. And since they give us the units in centimeters, this whole answer would be in the units of centimeters for the perimeter. When we're multiplying polynomials, we will need to take into account some exponent rules, and that would most likely be the power rule. So in our first example, we have 7y to the 4th, z to the 4th is multiplied by another monomial term. So 7 is multiplied by the other coefficient, negative 1. And then we have our string of variable terms. So I'm just going to rewrite those. Y to the 4th, z to the 4th, x, y to the 11th, z to the 5th. So taking care of the numerical coefficient, I would have negative 7. I have y, z, x, y, z. So in alphabetical order, x comes first. We only have one base of x. So I'm writing that. That piece is done. Next would be y. I have two different bases of y. 4 and 11 are the exponents. So when I add those together, I would have y to the 15th. Last, I have base of z. 4 and 5 make 9. I have each base written one time, and each base is written with a positive exponent, so that problem is complete. And now in example 2, you can see we have plus and minus involved in each of these quantities. So I will use the distributive property to find the final product. I'll take x and distribute that to each term in the other quantity. X times 2x means I'm applying the power rule. So I have 2x squared. Then x is multiplied by negative 5, so that's minus 5x. My next distribution is positive 3 times each term in the other quantity. 3 times 2x is positive 6x, and 3 times negative 5 would be minus 15. So you'll notice here in the middle, I have like terms, and those like terms need to be combined. So I have 2x squared as my first term. Negative 5 plus 6 leaves positive x, and the last term is minus 15. So when I multiplied those binomials, I ended up with 3 terms for my polynomial answer. Here we have some more examples of multiplication, and I'll distribute 2x to each term. So 2x, so 2x times 5x squared. 2 times 5 gives us 10. X to the 1 times x squared gives us x cubed. 2x times negative 6x would be minus 12x squared. Finally, 2x times 7 would be positive 14x. Then I'm distributing negative 3. So negative 3 times 15x squared would be minus 15x squared. So I'm going to write that below my other x squared terms to collect my like terms. Negative 3 times negative 6x would be positive 18x. So see how that lines up with the other x. And finally, negative 3 times 7 is plus 21, which needs a column of its own. So now that I have already collected my like terms, I simply go down the columns and combine them. So 10x cubed is the only cube term. With the squared terms, both coefficients are negative, so I'm adding them and keeping the negative. So that would be 27. So 10x cubed minus 27x squared. The first degree x, both are positive, so we're adding to get positive 32x. And 21 is the only constant term, so plus 21 is our last term. And what's nice about lining up these terms with their like terms right away is it saves you a little bit of effort when you have to combine them. Now the last example here already is in the vertical format. So we have 4x squared plus 5x minus 7 multiplied by 3x minus 1. So I'm distributing 3x times each of the terms written above. 3x times 4x squared would make 12x cubed. 3x times 5x would be plus 15x squared. Finally, 3x times negative 7 is minus 21x. Now I need to distribute negative 1 to each of the terms that's written above. And it doesn't matter if I start by multiplying the negative 7 or multiplying with 4, but I'll just keep going from left to right. Negative 1 times 4x squared would be negative 4x squared. So I'm looking at the exponents of the terms I already wrote so that I can line this product up with its same power. So I had negative 4x squared. Then I'm taking negative 1 and multiplying by 5x. That would be negative 5x. So again, lining that up with its like power. And finally, negative 1 times negative 7 would be positive 7. That needs a new column of its own. So when I combine the like terms, I know that 12x cubed is the only cube term. 15 take away 4 would be positive 11x squared. Negative 21 minus 5 would be minus 26x. And positive 7 is the only constant term. So automatically the terms are written from the highest to the lowest power. Here we have what are called special products because you can see that the binomial is raised to the power of 2. So that means we have 2 identical binomials to multiply. So we expand it first, and then you simply distribute like we've been doing. So 3x times 3x would be 9x squared. 3x times 5 is plus 15x. Next, you're going to distribute 5 times 3x to get 15x, and 5 times 5 for 25. Now do you notice here in the middle that the terms have doubled? And that's what happens with these special products. Sometimes the middle will double. So we end up with 9x squared plus 30x plus 25. The first term and the last term are perfect squares. And we'll talk about these perfect square trinomials in a later lesson. Now sometimes you have subtraction. So that simply means you are expanding this binomial. You have two identical binomials and both of them have subtraction. So when I distribute 2x to each term, I end up with 4x squared minus 18. And then I'll distribute the negative 9. So negative 9 times 2x would be minus 18x. And negative 9 times negative 9 would be plus 81. In the middle, you can see we have a doubling. It's just two negatives that are doubled. So the final product, 4x squared minus 36x plus 81. Again, the first and the last terms are perfect squares. In example 7, you'll notice that this is a little bit different from the other two because they are different symbols given in the binomials. One is plus and one is minus. Distribute like we have been doing. So we have x squared minus 6x, and then distributing 6 times x, that's positive 6x, and 6 times negative 6 would be minus 36. We do not have doubling in the middle. Negative 6x plus 6x eliminate. So we end up with x squared minus 36. This is called a difference of squares with no middle term. In the last example, 4x plus 3 is multiplied by a quantity of 4x minus 3. So they look identical except one is plus, one is minus. What do you think is going to happen with the middle terms here? Let's distribute and find out. So 4x times 4x is 16x squared. 4x times minus 3 is minus 12x. Distributing 3, I have positive 12x and minus 9. So again, you might have predicted that these terms in the middle are opposite of each other, therefore eliminating. We're left with 16x squared minus 9. And both of these terms are perfect squares, so we have another difference of squares. We'll be working with some of these special products in later lessons, so I hope you'll recognize them later on. The last operation on polynomials that we're working with today is division, and we are dividing by a single term. That's called a monomial. So 10x cubed minus 5x squared plus 20x is divided by 5x. What that really means is every term in the numerator is divided by 5x. So we call this the separate and simplify technique because we're going to separate our terms in the numerator and divide them each by 5x. This allows us now to simplify. So 10 and 5 have a common factor of 5, so when we reduce, we'll be left with 2. Now look at this. X is in two locations at the same time. We know from our exponent rules that we're going to be shifting the base with the lower exponent. So when x to the positive 1 shifts, it becomes a negative 1. So we're left with 2x squared. In the middle, 5 reduces with 5. X to the 1 is the smaller. So x to the 1 has the smaller exponent, so it shifts and becomes a minus 1. So we are subtracting x in the middle. Last, let's find out what we'll be adding. 20 divided by 5 is exactly 4. And look at these bases of x. They are identical. That means they reduce to 1. So we will not have any x remaining in our last term. 2x squared minus x plus 4 is the final answer. In example 2, 3x to the 5th y squared minus 15x cubed y minus x squared y minus 6x is divided by a negative x squared y. What this means is every term in that numerator is divided by negative x squared. So we'll separate and then simplify. So we have 3x to the 5th y squared is divided by negative x squared y minus 15x cubed y divided by negative x squared y minus x squared y divided by negative x squared y minus 6x divided by negative x squared y. So we need to look for some reducing, and don't forget about the signs. We've got a positive divided by a negative. So we will have a negative fraction for the first piece of this answer. Looking at bases of x, 2 is smaller than 5. So x squared will be shifting into the numerator, and that exponent becomes a minus 2. So far we have 3x cubed. Base of y to the 1 compared with base of y squared. 1 is smaller, so this base shifts up and we'll be subtracting that exponent of 1. So that leaves y. So we don't have a fraction remaining for that first piece. Next, notice that we have a subtraction sign and we have minus in our denominator, so that becomes plus. 15 is the only numerical coefficient. Bases of x, let's compare 3 with 2. So 2 is the smaller, that's going to be shifting up as a minus 2. Look at bases of y, they are identical. So the base of y reduces to 1. We have addition of 15 x to the 3 minus 2, that's just 1. Next, notice again we have subtraction and subtraction, so that changes to something being added. X squared, that's identical, that's reducing to 1. Y divided by y, again, those are identical, that reduces to 1. So what you end up with is 1 multiplied by 1 divided by 1 multiplied by 1. Well, that's just 1. And finally, with the last term, we have subtraction and a negative, so that will be plus. We've got 6 in the numerator. That's the only numerical coefficient. We've got 2 bases of x, but this time x to the 1 is in the numerator, and that's lower than x squared, so it shifts down with minus 1. We only have one base of y, and it's already positive in the denominator, so this last term will actually be a fraction. 6 will remain in the numerator, but x, y are both collected in the denominator. So it might look a little bit odd, but this is the way it's written according to our exponent rules. So I hope you found this helpful.